Unit 9, Worksheet 2, Distributive Property. This is just a review for you. You've been distributing hopefully since at least 7th grade, but distributive property is when we multiply a monomial into a binomial or trinomial or something larger. Like we could have, for example, 3x times 2x plus 1. So distributing means that we are going to take the 3x and distribute it into each term by multiplying. Think of like a distribution center. Okay, I think it's out in Madera. Vaughn's, I think it is, has a huge distribution center. And each day they load up the truck, and the truck delivers products to all the different Vaughn stores. Same thing here. We're going to deliver 3x to each term inside the binomial by multiplying. Distributive property means multiplying. So 3x times 2x, 3 times 2 is 6. And here, since we're multiplying the same base, we keep the base and we add the exponents. 1 plus 1 is 2. So 3x times 2x is 6x squared. Now, 3x times 1 is just 3x. That's distributive property. We could do that on a larger scale if we had, I don't know, let's make it even tougher. Let's go 2x to the third, and let's go 3x squared plus 2x minus 6. So now we're going to distribute a monomial into a trinomial. I really like to draw the arrows because it just kind of a reminder to make sure it goes to every term on the inside. So 2 times 3 is 6. X to the third times x squared is x to the fifth. I add exponents. 2 times 2 is 4. X to the third times x to the first, don't forget that's a first, is x to the fourth. 2 times negative 6 is negative 12. And the x to the third just comes along. That's what I usually say, but really, if you wanted to get technical, there is an x to the 0 power right there, because anything to the 0 power is 1. 1 times negative 6 is negative 6. And 3 plus 0 is 3. But usually I'll just say the x to the third comes along. So that's distributive property. Any questions on distributive property? Okay. One thing that students kind of get confused on, if you had, let's say, 2x to the third plus 7x minus 5, and you had a monomial at the end, like 4x squared, 3 times 2 is 6, and 2 times 3 is 6. The order in which we multiply things don't matter. Even though it's back here, we can still just distribute it like this. So 4 times 2 is 8. 3 plus 2 is 5, so x to the fifth. 4 times 7 is 28. 1 plus 2 is x to the third. And negative 5 times 4 is negative 20, x squared. Okay? Any questions on distributive property? Yes?
So if you have so say that last problem that you did, say you put another trinomial parentheses on the other side of the 4x to the squared, we would multiply to both sides, right?
Yeah, well, we're actually going to get into that right now. We call that, for instance, if we had something like, let's go x plus 2 times, say, x minus 4. Is that basically what you're talking about?
Yeah, but there'd be a thing in, like a 4x squared in the middle of those two parentheses.
We could do that, and we'll get there eventually.
Okay. Yeah, okay.
So remember, when you guys multiply more than two things together, like 3 times 5 times 6, you just multiply the first two together, get your answer, then you multiply it by the third number. That's the same thing. That's what you're asking about. Well, we call this, usually most math teachers will call this double distributive property, or the old term was FOIL. And I kind of like FOIL, even though after a while I'll start saying double distributive property. FOILing is kind of nice too, because if you think of FOIL, it's spelled F-O-I-L, okay? And we can use that acronym for F stands for fronts, and the front two terms are x, okay? And then outsides would be these two terms. So basically what I'm doing is I'm going to distribute the x into this binomial, fronts, and then these are the front two terms, and the x and the negative 4 are the outside two terms. And then I stands for the insides. These are the inside two terms. And lasts, 2 and negative 4 are the last terms. So you can hopefully see we call it double distributive property because we're just distributing both of these terms into this binomial. But FOIL is nice because fronts, outsides, insides, lasts. It's a good way to remember that you have to multiply all four terms. Okay? And when we do that, fronts, x times x is x squared. Then the outsides, x times negative 4 is negative 4x. And then 2 times x is 2x. And then lasts, 2 times negative 4 is negative 8. So everybody see how I did that? Yeah? Any questions there? All right. Now, what will usually happen when we FOIL, or double distribute, is these middle two terms, the O and the I, can usually be combined. The fronts, x squared, that usually won't change. And the lasts, negative 8, won't change. But the O and the I can usually be combined. And remember, it's negative 4 plus 2 is negative 2x. So when we double distribute, we usually take a binomial times a binomial and usually end up with a trinomial. Not always, but a lot of times. So that's what we call foiling. Okay? The reason we don't always use foiling is because we could do the same thing with x plus 2 times x squared minus 3x minus 2. Well, now we can't really call it foiling because there's too many terms. So we just call it double distributive property. And what I do is I'll distribute the x to every term on the inside, and then I'll distribute the 2 to every term on the inside. So you can see this could get kind of messy, right? So you have to be very orderly. X to the first times x squared is x to the third. X to the first times negative 3x is negative 3x squared. You can see I'm kind of writing small because I'm going to come up with 6 terms here. X times negative 2 is negative 2x. 2 times x squared is 2x squared. 2 times negative 3x is negative 6x. And 2 times negative 2 is negative 4. Everybody following that okay? I know you might not have been prepared to make something that big there, but now we have to combine like terms. Now the nice thing, like I said, the first, even in this case, won't change. It's x to the third. And actually, the last out here won't change either. So the first and the last usually don't change. It's all the inside stuff that's going to get combined. So let's see what we got. We got negative 3x squared and we got 2x squared. So negative 3 plus 2 is negative 1 x squared. I like to cross them out as I go so I make sure I get everything taken care of. Then I have negative 2x and I have negative 6x. Negative 2 plus negative 6 is negative 8x. Took care of those. And then that last, negative 4. Okay, so we just multiplied a trinomial times a binomial and ended up with a 4-term polynomial. Okay, to degree 3. All right, so how do you think you're doing with double distributive property? It's just a bunch of multiplying, right? Not too difficult. But I do want you to keep your eye on foiling because we'll use that in a couple days when we start factoring. In fact, we'll call it reverse foiling. All right, so let's do a couple together. How about 1, 2, and 3? You guys think you got that okay? Distributive property? Okay, let's do number 5 together. So I'm going to distribute the negative y to the first. Okay, so negative 1y times 5y to the third. Negative times a positive is a negative. 1 times 5 is 5. Y to the first times y to the third is y to the fourth. Negative times a negative is a positive. 1 times 3 is 3. Y to the first times y to the second is y to the 2 plus 1, or y to the third. Negative times a positive is a negative. 1 times 2 is 2. Y to the first times y to the first is y squared. And guys, I've been doing math for a long time and teaching math for a long time, and I literally do that in my head every single time. Of course, I do it very quickly, but I go through those steps, and I really hope you do too. It'll save yourself from making a lot of mistakes. All right, let's look down 6 through 12. Any of those you think you need help with? Think you can handle all those? All right, then let's go to the next page. All right, I'll do a couple of number 13 for you. This is something I was trying to explain to you last unit. This is combining like terms. If you have 3x's and I have 5x's, together we have 8x's. And the same goes over here for radical expressions. If you have 3 root 2's and I have 5 root 2's, together we have 8 root 2's. Okay? Let's go down to C. Now, this is a little bit different. 3x times 5x. 3 times 5 is 15. And x to the first times x to the first is x to the second. All right, well, how does that work with radicals? Let's think the same way. 3 times 5 is 15. And this is not how we normally do it, but let's think of it this way. Square root 7 times square root 7 is square root 7 squared, just like we did over here. But the square root of 7 squared is actually 7, right? Because square rooting something and squaring something cancel each other out. So what we really end up with is 15 times 7, which is 105. I'll leave the rest of those for you to do.
Can you do
F.
yeah.
Sure. Are those like terms?
No.
Can you combine like terms?
Yes.
No. I won't do F, but I'll do B. 3x plus 5y is 3x plus 5y. That's as simple as it gets. That should help you solve F. All right. So let's go down to, let's see, let's do number, let's do number 19. Well, number 19, some of you might go, oh, that's easy. That's 9x squared plus 1. No, that's not how it works. Remember, 3x squared is really 3x times 3x, isn't it? That's what squared means. If it was 3x to the third, then it would be 3x times 3x times 3x. So when we have 3x plus 1 squared, what it really means is 3x plus 1 times 3x plus 1. And now we have to distribute, or double distribute. So 3x times 3x is 9x squared. 3x times 1 is 3x. Now distributing the second term, 1 times 3x is 3x. And 1 times 1 is 1. The fronts don't change. That's 9x squared. And you'll notice the last doesn't change. But the O and the I, the outsides and the insides, will combine to give us 6x. So we end up with a trinomial, 9x squared plus 6x plus 1. And I'm just trying to show you, if you think about foiling, fronts, 3x times 3x is 9x. That doesn't change. And then O and the I multiply and add together to give us the middle term, and the L lasts. 1 times 1 is 1, and it doesn't change. Okay, let's go down and look at number 20. And it looks like we're going to double distribute or FOIL. Fronts, x times x is x squared. Okay, now outsides, right here, I like to do it this way. X times -7 is -7x. Insides, okay, 7 times x is 7x. And finally, lasts, 7 times -7 is -49. Combine the O and the I, we end up with x squared. -7 plus 7 is 0, and we end up with x squared equals 49. We call that the difference of two squares. Okay? So I like to do foiling fronts, outsides, insides, last. I like to do it this way because then you get a picture of Mario. Ah!
Wait,
If you do normal foil, you can get a parrot.
A pear?
A parrot.
A parrot? Oh, you have to show me that one.
So like, if
All right.
you're using normal, like,
Let's finish this up and then. Okay, so your job is to finish this page. Every problem. 9.2. Ready, break.